Assalamualaikum warahmatullahi wabarakatuh. First of all, I will introduce myself. My name is Muhammad Shaiful bin Muhammad Azmi, a student from electrical engineering course. Today, I will present to you about my project, simulation on the parameter of the three-phase system. Okay, for the first part, I will introduce to you about the introduction of three-phase system, parameter of three-phase system. Okay, this is three-phase load line. As you can see, this is the generator of load line, and EAN, ECN, and EBN is okay. This is for generator, and this is for source. Okay, this is three phase. I will explain about that. So for my project, my data that give to me is the power generated is 11 kV. Uh, so you can see the phase voltage is EAN, BAN, and ECN like this. Yeah, EAN, EAN, and ECN. So the phase this the three conductor are connected from AA, BB, and CC. So this of AA, BB, BB, and this is for C, C. And voltage from line voltage is called line voltage. So this is what we call line voltage. Yeah. So what happened is there is we call phase voltage. This is for load line. This is for generator line. So as you know, the source. Okay, we proceed to. So as we know, magnitude of line voltage is square root 3 times to the magnitude of phase voltage. So voltage line is equal to square root 3 voltage peak, voltage primary. Okay, the task that give to me is 2 wattmeter method. What is 2 wattmeter method? This method is commonly used in three-phase method in power measurement. So the current coil of the 2 wattmeter are connected series in two line, and the third line on which no wattmeter is connected like this. This is 1 wattmeter. This is 2 wattmeter. This connected on two line, and the other line is not connected. You can see like this. Okay, the 2 wattmeter is used for power measurement in three-phase system, irrespective or whenever the load is balanced or unbalanced, whenever star or delta connected. Okay. Okay, as you can see, this is full figure of 2 wattmeter method. So the objective that I present to all, if you can ability to evaluate the parameter of three phase, as you can see, I told you the parameter, ability to explain the detail and specific tool of techniques. I will tell you about later about the techniques and specific tool, and able to evaluate and analyze the active power absorbed by load using 2 wattmeter, and the study relationship between the sum of three line voltage and line voltage of three phase transformers. Okay, this is objective. So we proceed to the methodology. So this is flowchart of methodology. As you know, we commonly start with like this. Start. This is incomplete, because continue is behind. So we start with this, and the value of rated voltage line and generator load are identified. So, and the theoretical value of parameter is involved and calculated. I will show later. We can calculate IL, VO, VF, voltage drop, and so on. And active power using conventional method, measuring method, 2 wattmeter method. So since the piston just alone inductive in Henry, so the inductive load need to be converted in unit ohm. So we need to convert the inductive load to unit ohm first before we apply in piston. So after we all finish the calculation, the three phase of Y-Y connection are constructed simultaneously using piston. And after that, three phase sine voltage is found and value of line RMS is instead. The RL component ammeter, voltmeter are connected when all connected lah. And simulation are done and reading the parameter of three phase and simulate graph are recorded. I will show up after this. Then I will need to do the IE report written and the result and calculation of voltage drop analysis, and we compare the analysis, comparison discuss and end. Okay, I will explain to you all about my calculation theory. The task that given to me, the parameter value that given to me is Z load is equal to 61 plus J9 ohm, and Z line is 30 plus 18 ohm. Voltage generator is 11 kV. So to become the unit that we put to PC, we need to divide by Z3. So as we know, since the Z1 equals to Z2 and Z3, so the load line and load phase phase load is equal in 3, this 3 formula. So you need to divide by sum of 3, load line and load phase. So this angle is defined in what line you make. So for the line A, current for AN, you need to put the angle 0. So the load line, current line for PN negative 120, and for the CN is 120. So since we know that I line equal to I phase, so we need you just to copy back the answer. So I1, I2, I3, we know same as I line equal to I phase. So to calculate the V load, we need to put this formula time by load line equal to voltage load. So we know that formula is current time use current is time by inductor impedance. So the voltage drop, you can use this voltage drop 6.35 minus by 4. K bagi 6.35 100%. So the drop is 37.87%. So to calculate V4, we need to line I1. So I1 equal to Z load time with Z1. So use this formula, time with this formula, then we get this. Then for VP5, we need to use this formula times with Z load also times 4,529.68. We get the formula, we get this unit to get this value. And for VPC also, we need to use this time with Z load also. So we got this. So for voltage line, line 1, we need to VP for 4 time with this. So we got this. So and next we need to complete all the 3 lines. So line 2, line 2 and line 3. So time answer also. So we pick VP5 from here and line 3 we pick from here. And we got this answer. For VT, we got this, the line goes to I3. We got this. For VT2, we got this, the line kali I2 times I2. And for V3, the line times I3, got this. So we know that V line 1 equal to VW1. So VW1 times with I1 times with cos theta. So the time with cos theta and with I1 then with cos theta, we got that wattmeter for first wattmeter. And for the second wattmeter, we need to use the formula. You need to VLL2, this VLL2 time plus with 130 angle only. Then we got this. Then for wattmeter 2 time with I3 because it's on the line of I3 then with cos theta. So the angle is like this. Angle for voltage and angle for current. And we got this answer. Okay. Done for calculation. For next part, I will tell about data through PSIM. Since the unit of inductive load used in Henry, like I told you earlier, we need to convert in ohm. The frequency I refer to book state inertia standard equal to 50 Hz. So the formula is lateral value divided by 2 pi 50 Hz frequency, and we got this 0.0286. So this is answer for my simulation. This is for answer of simulation. This for table 2, this PAB, line voltage for AB, line voltage for VC, and line voltage for CA. So for the table 3, we got the voltage, simulated voltage for V1 is, so the answer is same, V1, V2, V3, voltage and generator. And for the load line, VAB is equal to 4.24, 4.21 volt, and VCA we got at 4.523. So value of simulated line current IL. So line IAB, IBB, ICC, and I normal line. So we got 54.9 ampere, 54.7 ampere, and 54.9 ampere. And for the value simulated load phase voltage VOL, VAN is equal to 4.524 kilovolt. For VBN 4.521 kilovolt, and for VCM 4.523 kilovolt. So this is answer for active power watt method. So for PA 3.513 3.3, 3.99.4 megawatt, 386.5 megawatt. So uh, this is graph simulation that we get from simulation. You can see that VAN, and this is for graph for VAN, VBN, and VCN. This is for voltage at phase voltage. Phase voltage. So you can see the peak is for, you can see this for a VAN, and say 4.524 like this, yeah, at this peak. Red is for VAB, blue for VBN, and the green for VCN. This is VAB, VAB, VAB. That's for line voltage. You can see that for 10.994 kilovolt. So you can see that the peak is 10.994 kilovolt. So for line with color red, we assume as VAB. For the blue, we assume that VBC, and for the green one, we assume as VCA. For the line current, IAA is red, IBB is blue, and for ICC is green. You see that? So the current is 4.524. No. Current is 54.9 ampere. So you can see that is from here, 54, 54, 54. So for discussion, the three-phase electricity consists of AC voltage identical frequently and similar amplitude. Each LC voltage phase is separate by 120 three-phase connections are suitable for design project because the three vector space voltage can be used to create a rotational field of motor like 120, 0 and negative 120, the angle. So motor this can result to the need for additional winding, and three-phase system can be connected to the load such the number couple connection required, and thus the transmission loss is one half of what they would otherwise be. The three-phase system each supply 6.35 kilovolt. As you can see, I already explained. So to supply the power voltage of 1 amp flow to the 6 wire, there are thus of 6 unit of loss to supply the power 1 amp flow to the 6 wire. Alternatively, the three supply can be connected to someone return when the load current is each phase is same. The load is said to be balanced. With the load balance and the three current phase shift by 120 from each other, the sum of current at any instant is zero. Then there is no current in return line. In the three-phase one system, there are only three wires are required to transmit the power that would otherwise require six wires. One half of the copper is required, and the wire transmission loss will be half. The wave of configurator can also single or three-phase to higher power load at the high voltage. On the half and the total load on each phase is shared out as much as possible to present a balanced load to primary three-phase supply. A wattmeter will provide accurate measurement of the true power, ampere power, volt ammeter reactive, power factor, harmonic, and many other over the broad range of wave shape, frequency, and power factor. Although only Two wattmeter are required to measure the total power in the three-wire system. As I showed earlier, it is sometimes convenient to use 3 wattmeter. And as a conclusion, as I was mentioned in the beginning, the purpose of this experiment is to investigate and analysis of electrical power system representing three-phase Y-connected generator, transmission loss, and load post resistance and reactance respectively for the dose equivalent circuit. The experimental circuit was then constructed in vSim simulator. Moreover, Y-bus and Z-bus results were calculated analytically, and then Y-bus results were compared to the empirical value of admittance taken from vSim simulator. In conclusion, we were introduced to PSIM simulator, tried to build simulated real power diagram, obtain the result, and compare to the analytical solution, and it can be considered that the goal were achieved. So that's all. Thank you. If you have any question, you can ask me. Send the comment below. Thank you.